Okay, let's go over the quiz. This is part of the review, right? The questions that are like this in the review, I'm not going to do again because we just did them in the quiz. Same thing with the homework from last time. So this is the properties of exponents, and it's got three variables, numerator and denominator. What do you do with the exponents when you're dividing? To subtract, right? So that would have made that a r to the -1. What about the s's? They cancel, right? S to the fourth over S to the fourth should be 1. If you didn't think of it that way, which I don't think anybody did this, wouldn't be wrong, but it'd be S to the 0 if you subtracted. And then t to the 6th over t to the -6, again, what do you do with the exponents? Subtract, and they don't cancel, right? 6 in the numerator doesn't cancel -6 in the denominator. 4 and 4, now those cancel, right? 6 minus -6 is 12. And S to the 0, anything to the 0 is 1. So this is t to the 12 over r. Right. Next. Simplify a radical. Okay, so we have a radical. Inside we've got a constant, and we've got variables raised to different powers. Is 200 a perfect square? No. But does it have any factors that are perfect squares? 100, right? So you should split this up as 100 times 2. Can we take out all of the a's as written? I mean, how do you determine if you can do that? Okay. So 6 divided by 2 goes evenly, so we will be able to simplify. We don't need to break it up, right? I'll write it here. And then b to the 7th, 7 divided by 2 doesn't go. How can we break it up into 2 different b factors? Yeah, think of what's the highest number less than 7, which is divisible by 2. 6, right? So we go b to the 6th times b. And now take the square root of every one of those. Right, the square root of 100 is 10. The square root of a to the 6th is a to the 3rd. The square root of b to the 6th is b to the 3rd. Right, and now put together all the things that are outside. 10 a to the 3rd, b to the 3rd. And then all the things together that are inside a radical, 2b. Right, the next one was a multiply and simplify. Right, what's the procedure when you're multiplying radicals? Right, the product of radicals equals 1 radical of the product. Right, so we make that the square root of 24 x to the what? X to the 6th, right? You add the exponents. 5 plus 1 is 6. That's step 1, right? Just doing that shows something. Okay, now we have to simplify. Is 24 a perfect square? No. Does it have any factors that are perfect squares? 4 times 6, right? Okay, will we be able to simplify all the x's? 6 divided by 2? Yeah, that goes. So we can just leave that as the x to the 6th. And this will be the square root of 4 times the square root of 6 times the square root of x to the 6th. 2 times the square root of 6, x to the 3rd. 2x to the 3rd times the square root of 6. That's it. When I'm looking at these, I tend to look at the numbers different than the variables. You know, they kind of require different skills, let's say. So do what you can. Don't turn them into decimals. Okay. We done? Okay, what the next one is a divide, right? We had a quotient property. How do you handle that? Make it one big radical, right? So this is the one where when we do it, we'll get the third root of 250 x to the 7th y to the third divided by 2x squared y. And with them all in the same radical, now we can simplify. 250 over 2, 125. X to the 7th over x squared. Okay. Y to the third over y, y squared. Okay, is 125 a perfect cube? As a matter of fact, it is, right? Remember, how are you going to, if you're not sure about your perfect cubes, how can you make a list of the perfect cubes? Yeah, make on one line in the calculator, make it the x squared and the next x to the third, so that when you look in the table of values, this is all the perfect squares, that's all the perfect cubes. So you need to be checking that list. Okay, so that's not a problem. How about the x to the 5th? Will we be able to split up all of those? No. So how can I simplify the most? X to the third times x squared. And how about the y squared? Anything we can do there? No. It won't simplify anyways. So we're taking the third root of all this stuff. 5x times the third root of x squared, y squared. Ready? What about the last one? Last one I said on the board, rationalize denominator. How do you rationalize the denominator when it's a monomial? What would I multiply by? The square root of 8x divided by the square root of 8x. You know, just showing that is a little bit of partial credit, because it shows you know what you're supposed to do. And you may not be successful after that, but at least you showed, you know, what was new about this kind of problem. What do you get when you multiply the numerators here? I mean, that's like this, right? That's like when you're multiplying radicals. What do? You just put them all together under 1, right? This becomes the square root of 40x. And what do you get when you multiply this? Square root of 8x times the square root of 8x. 8x. Okay, now, 40 is not a perfect square, but does it have any factors that are perfect squares? 4 times 10, right? 40 is 4 times 10. So that is 2 times the square root of 10. So here we've got 2 times the square root of 10x divided by 8x. And then there's a little more simplifying you can do. Yeah, this 2 divides into that 8, right? We can't touch the 10, that's underneath the radical, but we can definitely go the square root of 10x over 4x. And that's simple, right? You can't cancel the x's. You can't cancel the 2's and the 4 and the 10. That's the simplest answer. Any questions on the quiz? Learn from your mistakes, try to do better, replace lower quiz grades with test grades. So I'm going to go through the study guide is this. I'm going to go through each group showing you what we're trying to get out of those problems and what you're going to be asked. I mean, you're going to see the test. It's going to look a lot like that, okay? When it says find real roots, right? The square root of 4, you would say 2, right? 2, not plus or minus 2, just 2. Because when we use radicals, you assume a square root means the positive, the principal square root. Right? So you assume positive, not plus or minus. How about the square root of negative 4? It's not real, right? This says real roots. What kind of answer would you get if you did the square root of negative 4? It'd be imaginary. So when it says real roots, you just say non-real. Okay. The same thing true about the cube root of a negative number? You can do that, right? The cube root of negative 8 is negative 2. The cube root of a negative number is a negative number, right? Because if you multiply a negative together 3 times, a negative times a negative times a negative, you're going to get a negative, right? Right. So that's different than this kind of problem. If you're asked to solve a quadratic like this, and let's just say you solved it by adding 49 and then taking the square root of both sides, then you have to say plus or minus 7. When you take the square root, you have to say the plus or minus. When they give you a square root, you assume they mean the positive. I mean, just think if you would have solved this by factoring, how would that have factored? How would this x plus 7 times x minus 7, good mark. And so what are the solutions? Right. See, if you just said the 7, you wouldn't have all the answers. You've got to have plus or minus when you're solving an equation. Yeah, same thing. Okay, simplify radicals. We just did that in the quiz, right? Just a plain old simplify radical, so I'm not going to repeat that. Multiply radicals and simplify, that was the quiz question number 3. Divide radicals, simplify, that was the number 4. And the last, rationalize a monomial denominator. That was like quiz question number 5. But if you notice these problems, the group of problems that represents, they're all square roots, right? Square roots. Remember, it's a different problem. If I would have done something like the cube root of x over the cube root of y, then the procedures are not multiply by the cube root of y divided by the cube root of y. Right? That wouldn't work because what would I have in the denominator? I would have the cube root of y squared, and I still wouldn't be able to simplify. I would have to multiply by the cube root of y squared here so that when I multiplied these two together, I had the cube root of y to the third. Now that simplifies. Right? So, but these are all square roots. The test question will be square roots. It won't be one like this. I don't want you to be like looking at the problems there that do require that other thing. Right? So these are all square roots. Right? Not like this. Right, the next was, when is it that we can add and subtract radicals? When they have the same what? Radicand, meaning the thing inside, And index meaning the little number in the hook, or if there is no number in the hook, it means it's 2, right? What do you call radicals that have the same index and the same radicand? Like radicals, right? These are like radicals, right? Now, when you have like radicals, like we do in the first one, how do you add them? You add the coefficients, right? It's kind of like if we have like terms, right? If I had 10x plus 2x, you would add those together and have 12x, right? Remember, what is it that make terms like terms? You know, they're the same variables raised to the same power, right? So x to the first, that means you add the coefficients. In this one, we'll have 12 times the square root of 6. So these are like terms. This is like radicals. What about the next one? Can we add them up? Why not? Yeah, because this is a 3, and this one, although it doesn't have it in there, it's a 2. They don't match. Can't add. How about the last one? Square root of 3, square root of 2, they don't have the same radicand. So you say can't add. Okay. We good? Okay, well, what about these? Are they like radicals? They're not. But could they be simplified and then maybe they would be like radicals? That's what you have to try. You can't just say they don't work. Or the worst thing to do, believe me, somebody would do it, is say, oh, that's the third root of 70. No, it doesn't work that way, right? We got a procedure for this. You can't add these to, you know, what's underneath. It doesn't work that way. Let's put a big red circle. How's that? Okay, but 54 is not a perfect cube, but does it have any factors that are perfect cubes? Yes. 27 times 2, right? 16 is not a perfect cube, but does it have any factors that are perfect cubes? Which is it? 8 times 2. So the cubed root of 27 times the cubed root of 2 plus the cubed root of 8 times the cubed root of 2. Right? The cubed root of 27 is 3 times the cubed root of 2 plus the cubed root of 8 is 2 times the cubed root of 2, which is 5 times the cubed root of 2. Okay, rationalize a binomial denominator. Okay, it's a binomial and it has a radical in it. Right, what do you multiply by to rationalize a binomial denominator? Okay, what do you call that? You're saying 5 plus the square root of 7. He's right. You multiply by the conjugate of the denominator. And you remember what that word, the word for that is? 5 plus square root of 7. It's called conjugates. Right? That wasn't a good, let me make this a plus. It's not interesting if I just made them the same. Okay, so it's the conjugate of the denominator. So what happens when you multiply conjugates? No? All the radicals cancel, right? In the denominator here, 5 times 5, right? 25. Then the next two terms, right, are 5 times positive root 7 plus 5 times negative root 7. They're opposites, so they cancel. And then the last term will be negative square root of 7 times positive square root of 7. Negative times positive will make negative. And what's the square root of 7 times the square root of 7? 7, right? And then in the numerator, it's a FOIL. So this will be 25 plus 5 root 7 plus 5 root 7 plus 7. And you combine what you can. This is going to be 32 plus 10 times the square root of 7 divided by 18. Now, could that be simplified any? What's the common factor of the numerator and denominator? 2. So you could factor that out. Right, that'll be 16 plus 5 times the square root of 7 divided by 9. Again, you know, it shows something. If you just get this factor right, you know, that's something. You may mess up the part that comes afterward, but just showing that you at least know what you're supposed to multiply by. That counts for something. So try and get all the partial credits you can. Okay, the next are converting from the exponential form to the radical form. And how do I convert this exponential form to a radical? What's the index of the radical? So whatever is the denominator of the fraction, right, that makes it the 12th root of x to the 11th. Or, what's another way to write that? The 12th root of x to the 11th. Same thing. Okay, how do you simplify if you have a negative exponent? Flip it. So that's 1 over x to the 23 over 34. Okay, now we need to convert that to a radical. What's the index of the radical? 34. And what goes inside? Yeah, either x and then the whole thing to the 23rd, or you could just put your 23rd right there. Okay. Huh? You mean like, if this was like 10 over 12, would you make it 5 over 6? Yeah. You could. You know, the whole point of this is just like, do you know how to rearrange those numbers or not? So if you didn't, I wouldn't count it off, but you're not going to have a problem where they can be simplified. Okay. And then let's go the other way. It will. There we go. Now write these radicals as exponentials. Right? What's the denominator? It's a 7th root, so it's divided by 7. And then what goes in the numerator? 6. Right? And what about the one on the right? And the numerator is 6. It's the same. Right? Both of those are radical forms of the same exponential form. Again, it doesn't matter if the power is here or if it's here. Okay. Now, simplify an exponential expression. Right? What do I do about this parentheses raised to the 1/5 power? You know, you're going to bring it inside. You can think of it as a distribute, right? Like that. Negative 32 to the 1/5 times y to the 15th to the 1/5. Right? How do we simplify the negative 32 to the 1/5 part? Put in your calculator. Remember we said, you know, for that part of it, if you want to put it in the calculator, that's fine. Just make sure you use parentheses, -32, and then raise it to the 1/5 power. What do you get? Gabby? -2? And then what's the operation that goes on between these two? So multiply, right? So what is 15 times its density? 3. So that is y to the third. Okay, now the rest of these come from the homework last night. Since nobody asked questions on these, I'm going to go ahead and do some, the ones at the end we actually did. I've got them on the other slide. But let's just review, because not just this, in my other classes, in both functions and pre-calculus, we've just done chapters on logarithms and exponentials. And we had to solve those equations. It's like this, there was very finite steps to take. And so many go into the test and they don't even know those steps. I mean, you got to know the steps, especially when they're not that many. They're pretty simple. I mean, what did we say were our steps to solve a radical equation? Isolate, undo, meaning square a square root, cube a cubed root, whatever you're going to do. 3, solve whatever's left after you've done that. And you can check at that point. Check. I mean, this one in particular, if I was going to isolate, I would add 2 to the other side. 6 minus 3x equals 2. Undo a square root. Square it. Right? Now, the square of a square root, they cancel each other out. And 2 squared is 4. Subtract 6. Divide by -3. Two-thirds. Okay. Now the check part. Let's say that you plug that back in and you don't get the same thing. Because there's not an x outside of the radical, I would be suspicious that it's not an extraneous. It's just a wrong answer. You must have done something wrong. The extraneous happens because you did everything right. But it just happens to lead to that answer, and you cancel it because it doesn't check. But this 2/3, that ought to work. Okay, so now this one, I think we did this one already in the homework, but we didn't do it the way that the other way I showed in class, which you may want to. We can just see how that works again. You could convert this to a radical, right? We don't seem to have any problems with doing that. So let's convert it to a radical. That would be the cubed root of x plus 2. I'm going to do it twice like this. Okay, squared. No, is that right? No. That's the way that's not the way we've already done it. Of x plus 2 squared, and then it equals 9. And then undo that cubed root. It's already isolated. So undo it by cubing both sides, right? So that'll give us cubed and cubed. X plus 2 squared equals 729. And now in order to get at the x plus 2, which is being squared, what should I do to both sides? Take the square root, right? So this will be take the square root, take the square root here, and the square root here. Right, so this is x plus 2. And remember, when we take the square root, we have to include both the plus and the minus, right? So this is going to be plus or minus. What's the square root of 729? 27. So that'll give us x equals -2 plus or minus 27. X equals 25. X equals -29. Now remember, we did that one already. We did that one. Not there. You know, we did it right there. We ended up having to use the absolute value symbols. But the absolute value symbols just lead you to the same place of getting the plus or minus 27. Right, so that's, okay. Oh, sorry about that. Okay. Now, what would have happened if instead of doing it that way, what if we would have done it like this? Let's convert it to a radical, but this time we'll do it the other way with the power outside. So this will be the cubed root of x plus 2, and then we'll make that, the squared will be out here. Okay, so now take the square root of both sides. Is this going to work? I'm not even sure. The cubed root of x plus 2 equals, when I take the square root of that and the square root of that, now here I get the plus or minus 3. Okay, and now I've got to undo the cubed root. What's that? Because I took the square root. When you take the square root, you've got to include the plus or the minus. Okay, now what's going to happen? We're gonna do it twice, right? We'll do it once where it's the cubed root of x plus 2 equals 3, and the cubed root of x plus 2 equals -3, because we'll get different answers. Right? When I cube both sides here, then the cube of a cubed root gives me x plus 2. And what is 3 to the third? 27. So there's our x equals 25 answer. And the last one, I cube both sides here, and that's cubing a negative there. So that will give us x plus 2 equals -27. So x equals -29. Now, each one works out a little differently, but same answer. And the last, not that, solve where you got to check for extraneous solutions. And I think we did that one already a couple times in the homework. Right? That would have been like that one or that one. So just, do everything the same. When you get to the end, check. Yes. Or if you have an x that's inside and an x that's outside the radical. And you can see that in the study guide, there was not one like this one with 2 radicals. Right? So there's not one like that. Boy, what a question. Okay. Okay, this is what I've said every time that we've done this, okay? Every time. I said, you don't need to do all the problems, but you should do enough from each group so that you understand what the concepts are that are being tested. Don't just take the first one, put something down on paper, go to the next one. That doesn't do anything, right? Do something that probably like an odd number that you can check the answer in the back and make sure you're getting it right before you move on to the next one. Right? And then if you really want to test yourself, then make a list, just almost like at random, and pick one problem out of each group and just like write it down like it's a test you're taking and see how you do. Probably pick the odds that you can check in the back. And the ones you're not getting right, then you go back and do some more. That's what I would recommend. And Where are we at? There. That's the same study guide that was on every slide. So, and remember, everything that we've done in this chapter, the whole lesson is a video that's online and you can watch. I mean, especially when you ask me questions on the homework that are things like, I didn't get anything at all, and you clearly didn't do that. And I get a lot of kids that tell me all along that they're watching the videos, and then it turns out that they really weren't. And when I make them sit down with the video, they get up and say, wow, that was really helpful. Okay, that's what I've been telling you since September, right? It's a pretty easy resource there. You're not sure how to do something? The truth is we don't stray very far from the examples we do in class. Everything's pretty close to that. So you could just work on that, leave it up to you. Again, it's extra credit if you hand it in before, and if it's done well, you'll get the full credit. If you happen to fail this test, and believe me, lots do, and you didn't do a good job on the study guide, then you're not getting a retest. You need to prepare. And I'm here both days, before and after school.